Karissa Culbreath, Medical Director and Section Chief for Infectious Disease at TriCor in Albuquerque, New Mexico. TriCor is a very large integrated laboratory system that serves many hospitals, doctors' offices, and clinics in the state of New Mexico. We receive specimens from all over the state 24/7, and we are a very high volume lab with lots of microbiology and broad range of microbiology services in our laboratory. The improvements that we've seen in the clinical microbiology laboratory for efficiency and in quality have been much needed for a long time. Clinical microbiology really had largely remained unchanged for the past, 25 or so, even longer years. And so the introduction of automation into the clinical microbiology laboratory was really the first step in getting us to a place that we would be able to use some of those additional efficiency gains that we can get through artificial intelligence. One of the things that we know with clinical microbiology is that it's as much of an art as it is a science. And so different technologists may report different things slightly differently. There's always a challenge with staffing, and that challenge is increasing more and more. So by having artificial intelligence tools that aid the digital image interpretation, we're able to be more efficient with our training and help people to be able to be trained quickly and get them up to speed. We're also able to have standardization in the results that go out of the lab, irrespective of the technologist that reads it. Human error is one of the biggest challenges when it comes to any type of interpretation, any type of laboratory test that requires a human interpretation. And one of the things that we've noticed, and others have as well, is that there's really not much error with cultures that are completely no growth. There's also not much error with cultures where there's a single pathogen that's present at high growth. And those are the specimens that are really easy to interpret and get out the door, and there's very little differences in how people report those. But what we have found is that the errors and the differences, right? Sometimes it's even difficult to call it an error. It's just a difference in interpretation, a difference in even decision making of what the next step should be in the process. Really happens in the more complicated cultures that might have multiple pathogens of differing quantities of growth. And so what the Phenomatrix software really enables is to be able to provide some additional quantitation of how much of the organism by a more precise counting than just a human eye. And then with that, then the technologist is then able to make a better decision about what they need to do with the specimen on the next step and allow for more standardization. And so we have seen both improvements on the ends of the spectrum, where there's either no growth or one organism at very high growth. The benefit there is that Phenomatrix can very quickly categorize those and put them into those buckets so that those can be done and assessed very quickly. And then also Phenomatrix can help with the cultures in the middle, the cultures that are going to be more complicated, the cultures that might need more insight, the cultures that might need more assessment. If Phenomatrix can do then the counting of the different morphologies and the identification of some of the colony morphologies that are present, that takes away some of the sources of human error, and we're able to get more accurate results. And those decisions are able to be made more quickly in the lab, which leads to better efficiency. In our laboratory, we often say that automation and digital images give us the opportunity to time travel. And so with clinical microbiology, one thing that we know is that as long as the organism is going to stay in an incubator, it will continue to grow. And it will look different on day 2 than it looked on day 1 or day 3. And there are times that I don't get the questions, right, until day 3. And we always ask, well, what did it look like on day 1? How did we get to the place that we are now? How was this culture initially interpreted? What did they see? And before having digital images, we had to guess. We didn't know what the culture looked like on the first day. With digital imaging, we're able to look at the captured images on day 1. And so we can time travel. We can go back in time and say, what did this culture look like on the first day? And what decisions can we now make about the culture 3 days later because we knew what it looked like on day 1? I think the other thing that we're seeing is that we are able to really create training sets that represent the whole of microbiology. If we're honest, most days, for instance, on a urine bench, a technologist might only see 5 or 8 organisms, right? They'll see, E. coli, Klebsiella, some Enterococcus, some Group B strep. Maybe on a good day, they'll see Staphylococcus saprophyticus, but probably not. They might not see Corynebacterium ureolyticum, right? They may not see some of the less common organisms. And so what using these digital imaging training sets allows us to do is to present them with the full range of microbiology that they likely won't see in the days that they are training, in the months that they are training. And so we're seeing, right, better satisfaction with our younger technologists. They're excited to engage in these digital images. And we're starting to see improved quality. And of course, pairing that with artificial intelligence really just amplifies the improvements that we're seeing in our quality and the satisfaction that we're seeing with our employees. One of the first thing I see, right, for the use of AI is going to be continuing to amplify and develop more products to aid in the interpretation of the cultures. That is certainly the first step, whether it's aiding in culture interpretation of various specimen types, being able to do a more refined job in organism identification, or at minimum organism classification, and having regulatory approval along with that, so that those results can be released. I really think the next step then is getting into the additional components that technologists consider when fully interpreting the culture, right? And by that, I mean additional information from the medical record. So I hope that in the future, with AI, we would be able to bring in additional information from the medical record, additional information about the patient, about the antibiogram of the hospital, about past organisms that the patient may have had, and the antibiogram of those organisms specific to that patient, to really get us into this space of this personalized medicine for clinical microbiology that could be a more personalized interpretation of the culture. I believe the premier challenge that must be addressed and must be confronted, right, not avoided, is the regulatory landscape. Laboratories all over the world are seeing increased stringency when it comes to regulation. And so it is necessary for the laboratory to have a partner in this innovation process that is engaged and actively pursuing ways to address the new regulatory lens. I don't think that regulations will be decreasing, and so we must confront those head on. Without that activation, many laboratories' hands will be tied, and they will not be able to adopt even the most amazing technology if the regulatory compliance is not there. But further, the other challenge is that these technology is not inexpensive, and hospitals face also, and laboratories face financial challenges. And so thinking about how we can be able to demonstrate the value of the technology is really important. My lab is one that has been able to demonstrate that we've been able to achieve a return on investment. We've been able to grow as a laboratory and have new hospitals that submit their cultures to our laboratory without increasing the staff. And we've been able to include that volume in our laboratory because of automation and because of our use of digital image and assistive tools in being able to process those samples. When we think about the clinical microbiology lab, we are bound by time, right? And so in medicine, time is money, time is outcome, time is a change in antibiotics, and in some cases, right, time is the difference between life and death. What automation and AI assistive tools in the laboratory can help us close the time gap, right? And then it can help us close the outcome gap, which is the value gap. And so as we look at the role of the clinical laboratory, we can't, I would always say, I can't make these organisms grow faster. But what I have actually seen, though, once we implemented automation, is that they do grow a little bit faster in a more contained environment, right? So inside of the WASP lab and inside of this contained incubator, organisms that before they were growing a little bit slower because we kept opening and closing the door of the incubator. Now they're growing faster in this more contained environment. What that can translate to is a isolate that we are able to image earlier. If we can then layer onto that AI assistive tools to help to determine is there growth or is there not in a more timely fashion, and then move that through the process, we can help to improve and impact value. There's a story I've told for years since really we implemented the WASP lab in our facility, because it happened on about the second or third day that our WASP lab was fully implemented. Was that we got a call from a physician that was asking, basically, are you guys even actually doing microbiology in your laboratory? And I think you messed up my samples and you switched my patients with somebody else. I was shocked at the question, but I probed why. Why are you asking me this? And this individual, before we even implemented any tools other than the automation, he said the results are coming out so fast that I've never seen these results come out so fast from your laboratory. And I said, well, tell me more about the results. He said, I submitted a urine specimen yesterday afternoon, and by this afternoon I already have a result, and that was never the case before. Well, before we implemented automation, the specimen would come, we would plate it when we could, we would put it into the incubator. The technologist might be able to read it the next day, but often they would have to maybe go to the next day. If there was growth even on the specimen, maybe there wasn't enough growth to be able to do something with, and they had to subculture it. By having just the automation in the laboratory, we were able to significantly reduce our turnaround time on our urine cultures. And now that we've implemented other cultures in the lab, we've been able to significantly reduce the turnaround time. And so when it comes to value-based care, time is money. And now by adding on these other AI assistive tools, those results can come out all the more quickly, so that we can have a better impact on patients. This provider said, if I know that you can consistently get those results out and I can get them truly the next day, I'll be able to make changes in my practice knowing that I'm going to get those results out quickly. I'll be able to know that I may not need to treat somebody that I don't really suspect has a urine culture, but if I think the result is going to take 2 days to come, I'll have to treat them. But if I know you're going to get me those results in 24 hours, I can wait and call in the antibiotic the next day if I need to. That is value-based care. And that's a step that the laboratory can make towards value-based care, which is providing results consistently, accurately, and quickly so that clinicians can make changes in their practice.